What's up, everybody? I'm Matt Gary, and today I want to introduce Daniel, the newest content creator for Coding with the Force. When I started this channel, the only thing I had in mind was to create the highest quality Salesforce development content to you all for free. And thanks to Daniel, as well as other content creators this year, we're going to be able to provide you with more content than we ever have before. So thank you, Daniel, and everybody else so much. If you want to become a content creator, reach out to me and hopefully we'll get to work together. But for now, let's get on to the episode.
Hello everyone, my name is Daniel, and in today's episode of Coding with the Force, I'm going to be showing you how to mass delete records from Salesforce using either Batch or Queueable Apex. Alright, so recently at my job, we ran into an issue where we had too many old records hanging around the org that we didn't need anymore. While we weren't running up into data storage issues, we did run up against selective query issues, which you can hit when you have millions of records, and that led us down a path of discovery to figure out what the best option would be to keep those records under certain thresholds going forward as we continue to accumulate them daily. Of course, if it's a one-time thing and you just need to delete some records from your org, you don't need to get into Apex. You can just do a data loader bulk delete and that'll solve your problems. But if you have a need to continuously keep deleting certain records based on a criteria, then I'm going to give you some examples on how you can accomplish that using Batch or Queueable Apex. So I am limited in a dev org about how much data I can create. So in this org here, I've maxed it out with 20,000 cases, and I'm at 113% of our storage used. So the example here, we're going to go over how to delete a majority of those. But in the examples will work up to millions of records in any org, just using the same techniques. So for our example, I have filled in a whole bunch of cases into this org, and what we're going to be targeting is any case with a status value of archive. So we've established in this theoretical scenario that we have cases existing in the org, and when some automation or certain date is reached, they are given a status of archive, and then our tool is going to be deleting those from the org. So we're going to jump right into Visual Studio Code. I'm going to create a new class here using the SFDX extensions. So in this class, I'm going to be calling it Delete Records Batch. I'm going to put that in the default directory, and that's going to generate a basic stub class here. Of course, for our batch class, we need to add the implements database.batchable s object decorator here. And then in our class, we need to implement 3 methods to meet that interface. So the first one is going to be a public static database.queryLocator method. And of course, that one is called start. This will be the first thing that it's called when your batch job is scheduled to gather the records that the batches will chew through to do whatever actions we need to do. And then this is going to take a database.batchable context parameter. And of course, since it is a database.queryLocator method, we need to return a database.getQueryLocator function. So what our query is going to be is we are going to select ID, because that's all you need to delete a record is the ID, from case where the status is equal to archive. And of course, we need to escape those single quotes. And if I could spell, there we go. Escape that one, and then end with an extra one. So this is going to query all the records in the org that meet this criteria here, where status is equal to archive on the case. But in your org, you could do any criteria that you need. So if you want to delete things that were created before a certain date, you could do that. If you had different status values, you could do that. Any combination of what a SQL query could return is what you could use here. And of course, anytime you want to delete records from an org, you want to make sure, one, you have permission to do that, and two, take a backup of the data so that it's not lost forever before you run anything that can be deleting things. And then also make sure you test it very thoroughly to make sure it's only deleting the things that you intend to delete. The second method that we need here is the execute method, and this is what's going to be called for each batch of the job that runs. And it's going to be a void method that's called execute, and it also takes a database .batchable context variable parameter. And in this one, what we're going to do is actually do the deleting. So if you're familiar with a batch job, what it does is it takes a whole bunch of records, up to I think 50 million. It chunks them down into smaller batches, and each of those batches gets run through the execute method. So in this one, that's where we're going to be trying to delete the records. So we're going to do a try catch, and we're going to say delete scope, which reminds me that we need a second variable here. That is the actual records being passed into the execute, which is the case records. It's a list, and we're just going to delete those. And then for error handling, we're going to catch any exceptions that happen. And then for now, we're just going to log those to the console. But if you are in a production org, of course, I urge you to have some sort of logging framework that you can use to track and monitor these. If you haven't checked it out, you might want to look into Nebula Logger. But for now, this simple debug statement will tell us if anything happened. The last thing you need in a batch class is a static void method finish. This will get called when your batch jobs, all of the chunks are completed. And then that will be any wrap-up material you need to do. You can send an email, log any data that you want. And here we're just going to log another message to the console saying that the batch job is complete. And then for consistency, I'm going to put in a system debug here so we can monitor it as it's running. And then in the start method, I'm also going to put a system.debug so we can see that the batch is starting. So if we wanted to check the logs while it's running, we could see which stage the log is for. So there's one debug for each. All right. I think that is everything we need for this batch. It's pretty simple. Let's push it to the org and see what we get. Looks like I typed everything right this time. So if we want to run this batch, of course, you could create a schedulable class and have that running daily or weekly and calling this batch whatever time period you need. But for this example, we're just going to create a little bit of anonymous Apex that schedules the batch for us so we can see it running in our org. And just a reminder, we have right about 21,000 cases in the org. And if we were to go into developer console, we could query from our cases where the status equals archive, and we're going to see how many will actually be deleted out of those 22,000. All right, so we've got about 18,500. Make this simpler, just do a count of IDs. So we've got 18,500 that we expect to be deleted, and the remaining about 2,000 will be remaining in the org after we run this. So in Visual Studio Code, you can run anonymous Apex. They give you a sample file here in the scripts folder. You can store it, you can run just what you select, you can run the whole file based on what command you have. I'm going to replace this here, and I'm going to use the database.execute batch method, and this gives you two parameters. The first one is the class that you want to execute. In this case, we're going to do a new delete old records batch. And then the second parameter here lets you specify the size of those chunks in the batch that will be executed. If you don't provide one, the default is 200, and that works fine for most cases. But here where we have a very simple batch class where it's just deleting the records that are in there, we could actually give it up to the max, which is 2,000. And depending on your org, you should be able to do that without any performance degradation. And that'll just run less batches, so the job will finish more quickly. So that's all we need here at database.execute batch. Pass it in an instance of the batch class, and then the size of the batches that you want to run. And then in VS Code, you can either use the command palette to do execute anonymous Apex with editor contents, or there's a link usually at the top that just says execute anonymous apex. You'll get the results from that down here at the bottom. And because we're just scheduling the batch, and the batch is an asynchronous operation, it returns really quickly. That batch is in-queued into the background for when the server has time available. If you go into your debug logs, you'll see here that the batch was scheduled and it was started, and we're running through the batches now. So each time the execute method is called, it starts a serial batch apex range chunk handler, and that's what each of those chunks is eating through. Fun fact, your batch job is not guaranteed to execute in the order of those chunks based on the query. So if you had ordered this query here based on by say create a date, there's no guarantee that the execute method is going to execute in order of those chunks. It's just up to the server's decision on how the resources are allocated, but they will execute through all the chunks. One good thing about a batch job here is if there is a single failure in one execute statement, that won't break all of the other chunks going through. So you'll delete most of it, but if there's one error somewhere, it won't break everything. That is one reason you might want to consider a lower batch size. You would have less records impacted at once. But if you don't typically have any errors deleting anything, you shouldn't see any impact there. So each of these should have a message that says batch is executing. And then the final one here, you'll get another batch apex operation with a debug message that says batch job is complete. So if I close all of these tabs here and go back to our query editor and select again the records count for where status equal archives, I should see 0. So all of the records that have that status have been deleted. And again, if you wanted to schedule this to run weekly, daily, it would keep your org clean and all those records would be cleaned out. I'm going to reset the data in the org running a script here while I continue to explain the benefits of batch apex. This is a very simple example. It's very easy code to make. If you don't have a super complex org, that's probably what you should stick with, but there are some limitations to keep in mind. For batch apex, you can only have 5 batch jobs queued or active at a time in your org. So if you have a lot of batch jobs running or a lot of things scheduled already, maybe we will look at that queuable example next. Another limit is that you can only have 100 batch jobs holding in the flex queue. Most people probably won't hit that, but it is something to keep in mind. The third limit is that your org does have a daily limit on async execution methods. Daily async method execution limits. So basically what that means is for each of these methods, that each time they're executed, so one time for start and one time for finish, and then each chunk is an execute, all of those count against your daily async executions limit, of which your org has an org-wide 24-hour limit of either 250,000 or some multiple of your user licenses. Of course, unless you have millions and millions of records, you probably won't hit that because batch is pretty safe to use. All right, in my org, we already had quite a few batch jobs running, and I thought I would look into Queueable as an alternative, so that's what I will show you next. So I'm going to create a new Apex class that is going to be delete records queueable. Put that in the default directory as well. And to implement a Queueable class, you need a different interface, and we're going to be implementing the Queueable interface. Nice and easy to remember. And again, here we will delete the default constructor, and we will add in a execute method. So we need a public static void execute, and that is going to take a queueable context instead of a batchable context. All right, so by default, a queueable is a single execution. So if you want something similar to the batch where it's chunking through millions of records at a time, we're going to have to make this queueable self-chaining. We're going to enqueue itself if there's more records to process. One thing to keep in mind is that it won't do that chunking for you automatically, so you are subject to the limits of your transaction. And if you're familiar with Salesforce limits for async transactions, the default DML limit, of which delete is a DML operation, you can do up to 10,000 of those in one transaction. So if you don't have any before delete triggers on the object that you're trying to delete, it should be safe to delete up to 10,000 records in one transaction So for each chunk of the queuable execute method. So what we're going to do is generate a list of case records that we want to delete. And then we're going to query for them by doing a select ID. Again, that's all you need. From case, where the status equals archive. And then important here, you need to limit it to that 10,000 number, or you'll get a DML limit error because you tried to do too many in one transaction. And then all we got to do is that same thing we did before, is try to delete records to delete and catch any exceptions that occur. And in this case, we're just going to, again, system.debug those errors. But you should have a stronger logging framework to use. And then in here, we're going to put a system debug message. Queueable is executing here. So this should delete 10,000 at a time. In our org, we have 2,000 here, so we need to run it at least twice. If you had millions of records, you would have to run it however many times you need for meeting the target you're trying to do. Now, so the execute method needs to call itself again. And what we're going to do here is use a new feature in Apex that they have for safely doing this. But first, let's check to see if there's actually still records. So what we're going to do is before we want to re-enqueue itself, we want to make sure that there is not an infinitely running chain of operations running, because again, you'll chew through that daily async executions limit very quickly and your org will be stuck. So we don't want to run this if records to delete size. We don't want to run it if the collection is empty, if it doesn't find any more cases with a status of archive. We don't want to enqueue itself. But if we left it at just this, what would happen if there was an exception? Because we're catching it, it would keep enqueuing itself and keep failing, and you would eventually hit your limit. So what we're going to do is add an additional check for a new feature that Salesforce has offered. I believe it's generally available in the upcoming winter release. And that is the async info class, which provides you with these 4 methods here. And these allow you to control the maximum depth of your queuable job and how many times it can enqueue itself, so that you don't get an infinitely running loop chewing through your limits. So the first one just tells you if you have configured a max stack depth, and then the other ones are calculating the current stack depth and what the actual maximum stack depth is if it exists. The last one is a delay timer that you can do. So it will wait a certain amount of minutes. I believe it's from 1 to 10 minutes before it re-enqueues the job again. And that can also help you with either rate limiting or setting your class to make sure it doesn't instantly re-queue and queue itself and keep going and chewing through your limits. I'll show you how to pass these in, but for the implementation in the class itself, what we're going to do is if the records to delete is not empty, important correction there. So if it's not empty, there are more records to delete, and the async info class has a max stack depth here. And then additionally, if the async info class current stack depth is less than the async info dot get maximum queuable stack depth. So if there are more records, if the query has found values in the current execute, if we have configured a maximum stack depth that the queuable chain is allowed to go to, and then if the current stack depth is less than the maximum stack depth that we have configured, then the job will system.enqueue, and then we're going to pass it a new reference of delete records queuable. And what this will do is just take this same class and pass itself in, and it's going to do similar to the batch job chunking, but it's going to do it queuable instead. Instead of 2,000 at a time, we're going to be doing 10,000 at a time. It's very important to have a guard clause before you self-enqueue, like I said, to prevent running into your limits. All right, so we're going to deploy this to the org. And then while that is running successfully, we're going to go back here and make sure that the org has reset itself to make sure we have records that will be deleting. So we have 18,500 cases that are back in the archive status. And then we're going to configure that async info options for the scheduling of the class. Again, Queueable can be scheduled, but in this example, we're just going to call from a non-apex to run it one time because we only need to do that in this example. And what we're going to use is the system.enqueueJob method, and we're going to give it a reference to the delete records queueable class, and then we're going to pass it an options parameter. And you must be asking, where does that options come from? Well, from that async info class. So we're going to generate a new async info options instance, and we're going to set that equal to new async options. And then there's only one thing we're going to configure here, and that is the options dot maximum stack depth. And excuse me, I have to try to remember what the setting is. Maximum queueable stack depth. So we're going to configure the async info maximum queueable stack depth. And because we know there's only 20,000 records, I can hard code this to 3. And that'll just make sure that it only runs 3 times. But you could dynamically configure it. You could query for a count of how many records there are. You could set it to a number slightly greater than the volume of records that you have coming into your org, just so you set a cap there so it doesn't run through your 250,000 execution limit. There's a lot of options, but it is important that you have something here so that it does keep enqueuing safely. All right, and then let's clear our debug logs so we can see the Queueable job run. And then we're going to hit execute again, and then that should enqueue a job. Here we can see that there was an error. All right, illegal assignment from async options to async info. Ah, yes, it is async options and not async info, I think. Yes. So let's try that one more time. And now we see that we have a one job added to the queue. And if we go back to our debug logs, we should see this job pop up a couple of times as it executes and deletes those records. Queueable is also an async operation, so it gets added to the background jobs list, ready for resources available on the server for it to run. There we go. So we got the first one there, Queueable handler, and the Queueable is executing. And if we scroll through the debug statements, we should find a SQL execute where limit 10,000, and it did find 10,000 records to delete for that one. So it's deleting those 10,000. Queueable is exiting. All right, now we got the next one. Queueable is executing, and in this time, it should only show about 8,500. Yep, 8,500 here. And then the last one, Queueable is executing. What happens is, even though we only have 18,000 records in the Queueable class itself, when it does find those last 8,500, we're still within the limits that we have established here. And because the list is not empty yet, because the items were deleted, it does enqueue one final time, but that query will find nothing. If we go into here and find the assignment, we should see nothing was found. Yep, so list here is empty, and then the Queueable will it won't match this statement here, and it will end. All right, so that gives us a Queueable option to do the same thing. Hopefully that also helps you kind of explain how a Queueable chain works if you wanted to use it for something else. This situation, I would most of the time recommend you do a batch job, but I think Queueable chaining does have excellent uses in other places. I think that will be the end of this video. We can confirm that the records were deleted, of course, by going back to our query, searching for where the records that have a status of archive, and we have 0 again. And then if we go to our storage usage and refresh that, we should see now we are under our limits, back down to 33% of the org, and potentially we now are able to create records again. That's all I've got for today. If you enjoyed this video or you have any feedback, let me know down below, and I hope to see you in the next one.